Hello everyone and welcome to my final project, my CS Practicum. Really excited about this. I'm really happy about the work and what it's turned out to be. So I'm going to go ahead and just jump right in and walk you through it. So we're going to start with the background and problem description. So we know that home routers and Internet of Things devices are used for botnets, different types of attacks on the internet, and there's a big security problem with it. So we know that home network routers, typically Linksys, ASUS, standard routers, have basic firewalls out of the box, but you don't really get to see what's happening with them. So a lot of advanced users will put their own firmware on the routers so that they can kind of have more control over what happens with that with the network. And sometimes they'll even buy a small form factor SFF device, like a Linux router, basically. And they'll put Linux on it. So the problem, though, is that the small form factor devices require money up front. They're about $200 or $300. I looked into it myself recently, and they're powerful, but you have to have that investment up front, and they're required for the fully integrated firewall solutions that you see, like IP Fire. So basically, the way this works is you can flash a standard router most of the time with custom firmware like OpenWRT or DDWRT. And so there's a niche need to kind of just, once you set that up, to just have an application that's ready to go that can show you what's happening on the firewall. When you look at the actual log data inside of the routers, it's just basically packet logs and dashboard stuff. You can do it to integrate with IP tables based firewalls is what I'm using, but it can be better set up. So my solution is the Firewall Status Display, and it runs on Windows 10. It's open source. It's in GitHub, so you can check it out. You can customize it. It's designed to run as quickly as possible out of the box. Prereqs are pretty simple. .NET Runtime 6, SQL Server Express. You can utilize an instance of SQL Server you already have running, like Developer Edition, for example. Then you don't have limitations. And you need remote syslog to be pointing to this IP address that's running this. So the features are, there's a status dashboard, geolocation information. It can detect port scans. There's alerts. You can minimize the system tray. You can filter and sort, and the log parser is designed to be general to be used across multiple different types of platforms, which I'll show you here shortly. So I'm going to go through a demo of the program right now to get started. So when you open it, you get to see the dashboard. As you can see, there's traffic broken out by country, ports, the port scan list, and some statistics on it. So, for example, you can see here a pie graph of the drop packets, most of them from the United States, second place is Netherlands, third place is Russia, for example. Similarly, you can go to ports. They'll tell you the types of traffic. Telnet attacks seem to be very popular still, passwordless telnet servers. HTTP alt, which is basically your 8080 port for home routers. So that's, a lot of people leave their home routers open with the admin password set to blank or just admin or whatever. SSH is another popular attack surface, and you can see there's other variations of that. There's remote desktop, for example, and port 81, which is an alternate HTTP server. So when you go to this tab, it shows you the port scans. So I have a graph here that shows you port scan history by date. So as you can see, I've basically set up a lot of port scans. Here I've done some test ones. So I'm going to start another one right now just so you can kind of see how this works. So I'm at this website that's a UDP port scan tool. So I'm going to start that now. And within a minute, you'll see the alert come up. So in the meantime, I'll show you the app. So, and then the last tab is the statistics, which just show you how many packets have come through that have been logged. We have 28 days worth of packets. So there's the port scan right there. You can see basically that it showed the port scan successfully when basically within 30 seconds of it coming in. So you get the alert there, it shows you there's a port scan. And so back to statistics, it's just basically just shows you some data about the logs, the packets that are coming in and a graph. I'm going to clean this up. This is just for, for right now, but I'm going to break this out by week because I got too many days worth of data. So the next tab is just a syslog that just shows the raw data that's coming in. This is mostly for diagnostic purposes. Then we have the firewall log, which will actually show you the packets that have come in. And the nice thing about this is that you can sort this and filter this. So each of these columns in the grid have different fields. You can do greater than or equal to, for example, for source port, destination port, and so on and so forth. Protocol, you can filter by TCP, UDP, ICMP. And over here, you can see the length of the packets and so forth, and you can see the source city of the packets. So Moscow, for example, obviously it's Russia, and where it's coming from, where it's going to, which is basically to my house in Henderson here. So last part is the settings. When you run it, you can import the database. So it makes it pretty simple setup. You can import a geolocation database. It'll open the website and allow you to download it. And when you import it, it supports compressed files or CSV files, and it will import that into the database for you. So that's the app. I think the app's pretty straightforward. So when you go here, this is the firewall that I'm SSH into. This is my router. So I just have it set up for remote syslog to go to my IP address, which is this one. So, and then this is the database here. Firewall status data, and here's the tables. So I have one table for the actual firewall entries, another table for the geolocation data. So you can see this all in a SQL server, and it's all organized and stored in here. So this is where the application gets its information from. So now that we've discussed the demo, kind of just showing you the app, let's go over the evaluation. So I'm going to try to sum this up because there's a lot of stuff potentially to evaluate. I've broken it into 3 parts. So we had the list of the top 3 offending countries: United States, Netherlands, Russia, and then the top 3 targeted services. So here's basically just a screenshot of what I showed you already. This is the graph, the pie chart, sorry, of the ranking by the countries, the percentage, number of packets, and then also the ranking by the services that were dropped. So I have all these filtered, obviously, so that's why they show up here. All right, so the second part is going to be different firmwares. So what I did was I have another router that I had DDWRT on, so I used that. I developed this whole thing on OpenWRT, so it works perfectly with that already. So DDWRT, it works on that too. There is a slight annoyance with it, though, that BusyBox only gives syslog packets up to 256 bytes, but it still detects the geolocation data and the IP addresses just fine. So there might be some minor tweaks there to the actual DDWRT configuration to make that output longer packets. That just gives you the packet flags, for example, for future development. And then I also installed a virtual Ubuntu server, 22.04, and I set up the UFW firewall on that and redirected everything to the app, and everything worked fine. Everything showed up, and here's a display just to prove it. So here's the information from the OpenWRT, DDWRT, and then of course Ubuntu. So you can kind of just see the difference here. The interface names are different on each platform, and that's how you can kind of tell. And the rule names are different too. For Ubuntu, it's UFW block. Okay, so third part about the evaluation. Basically, this is going to be evaluating against other solutions. Now, this is a niche product, so this is not. It's very easy to say, like, well, why not just use this or that already exists? And that's a valid question. This is not meant to be a full feature-rich solution involving heavy infrastructure. This is just basically to show your firewall information, and that's it. There is reporting on it, and there's still a lot of customization that can happen. So just to kind of walk you through it, the requirements are SQL Server Express. This will store about 15 to 20 days worth of data. It has a 10 gigabyte limit, but you can install SQL Server Developer Edition depending on your use case. So once you install it, you install SQL Server Express, .NET 6 runtime, 150 megabytes of space for the app, and then you run it, you import your geolocation. It takes about 15 minutes, set up your remote syslog, and that's it. You're good to go. It shows you everything that's happening on your firewall after that. So just evaluate it for a couple other ones. So versus Graylog. Graylog is just a general purpose logger, but you can set up dashboards, for example, for IP table logs. But that requires a separate virtual machine. You typically want to install Graylog on its own virtual machine because it uses a lot of services. 4 to 8 cores, 64 gigs of memory, a lot of hard drive space to crunch the logs, because again, it's not meant for just firewalls. Graylog is a full feature solution. Similar with Splunk. Splunk is a very good program, and it can certainly do what this program does. But the infrastructure requirements, again, for Splunk are pretty heavyweight. You have to, for Elasticsearch especially, those are it's kind of the thing that really gets these apps, is the Elasticsearch requires a lot of stuff. So, and there's no out-of-the-box dashboards for either one of these two solutions. You have to set those up. Those may or may not be maintained. There may be new versions of Splunk. I'm going to go over this more in the evaluation in my final report, just to kind of really go into detail with this. So the other two were Alien Vault, OSSIM, which kind of looks interesting. This Alien Vault's flagship product, but essentially it's sort of the same thing. It's unclear what the firewall information is. I'm going to go over this more in my final report, but basically it does have heavier requirements. Not as bad as the other two, but you're still talking about more or less it running on its own virtual machine. So the last one's IPFire, which is really nice. I would actually use IPFire if I had the hardware, if I actually had the device, but it needs to run on its own firewall, and that needs to have two NICs. So that's just it. But the nice thing about IPFire is it integrates directly with the firewall. So it has the features, and you can block traffic basically immediately with IPFire. So it's very good, but IPFire doesn't apply to these types of situations where a user already has a router. So limitations of this product are basically that SQL Server itself only supports 10 gigs, which I kind of touched on before, but you can use Developer Edition depending on your use case. If you're a developer, you're just, hey, I'm just developing, so I have a developer database, and that doesn't have any limitations on the size. The ad hoc reporting isn't really there. I'd like for it to be in the future, but right now, just to get this project done in time for the semester, it just has the static reports that I have. The graphs that you see are basically it. But there is the potential, at least, which I could probably implement quickly in the future, is just an exportability to export the data to an Excel sheet, and then you can run reports off that if you'd like, or perhaps another database, another reporting module. So it only runs on Windows 10. I don't have a Linux version or Mac OS X version, and it only shows firewall data. And the other limitation is that you can only view things that are happening. You still need to take your own action if there's a threat. So future work is basically add support for MySQL, another database solution, further UI integration, like being able to right-click stuff and go to other parts of the app to quickly kind of move around the app. Right now, you have to click everything manually. So that wasn't really necessary for this stage, but I do want to put that in there. I still plan on developing this after the semester's over. I want to add a database list option in case somebody doesn't want to install SQL Server, using a web API for the geolocation. So that's also another option. Of course, it'll only be limited to data that's in there while the app's running. More dashboards, more alerts, more customization for the dashboards, more filtering are all awesome features I want to add. Hence, to actually give you IP tables rules that will show you what's happening with the traffic, like what to block, geolocation stuff, and to also allow allowed and rejected traffic to log those too. Because right now it's only showing the drop traffic. So why use this? I kind of touched on this anyway, is that there's other solutions, but there's hardware investment. This runs on Windows 10, which has a huge market share for desktops. The alerts show up, and it has high functionality out of the box. You don't really have to customize it that much. It's basically ready to go. So the prereqs are pretty low also. So this is basically a good solution for someone who just wants to get going right away with their firewall and just show you what's happening with it, and that's it. Pretty niche, but pretty straightforward application. So that's basically it. That's all I got, and thank you for watching.